Forget the moon. Everyone wants to go to Mars. In the last few decades, we have sent landers, rovers, and satellites to the red planet. But we haven't sent any humans. So the big question is, can we? And if we can, what would we do when we land on Mars's surface? Despite all our Martian excitement, the reality is Mars is too harsh for humans to survive. There is no oxygen in its atmosphere, and the surface of the planet is way below freezing point, and the planet's gravity is just 38% of Earth's. So what are we going to do to survive when we eventually land on Mars's surface? Welcome to Future Mission. Join us today as we explore the possibilities of human survival on Mars and what would likely happen the moment we land on the red planet. Before we begin, we need to answer a very important question. Out of all the other 7 planets in our solar system, why Mars? The reason is Mars is the only planet that exists in the circumstellar habitable zone, a fancy name for planets that can support liquid water if they have sufficient atmospheric pressure. Water is life, so planets that fall in this zone have the potential of supporting life. Unfortunately, the only other planet that falls in this zone is Earth, so we are stuck with Mars. The first people to land on Mars will be scientists of various fields. They will be the best at what they do because their main goal will be terraforming Mars. Many scientists have come up with the most bizarre ideas of terraforming Mars. Some have suggested nuking the planet so that it develops its own atmosphere, while some have suggested building electromagnets to alter Mars altogether. While these ideas might seem fancy and almost sci-fi, they are unfeasible. The process of terraforming Mars won't involve explosions and items from a Philip K. Dick novel. Instead, it is a fascinating, deliberate process that has already begun here on Earth as you watch this video, and we will explain it better if you stick around long enough. For now, let us talk about the rockets that will send our colonizers to Mars. Let's talk about Starship. This SpaceX vessel is made up of 2 parts, the spacecraft and a huge booster rocket called the Super Heavy. The spacecraft sits on the booster rockets, and together they tower 120 meters high, which is the size of a football field and taller than the Saturn V, the rocket that sent the astronauts to the moon in 1969. This means that there is enough space for people and supplies that will be sent from Earth. Starship can carry up to 100 people, and it can also lift off cargo of about 21 metric tons, which is the equivalent of 5 African elephants. Now, with everyone in the Starship, how will they take off from Earth and how will they land safely on Mars? First, we would have to make sure Mars's orbit and Earth's orbit are at their closest. Starship is launched from Earth's surface using SpaceX's Super Heavy booster, which is reusable. So they will separate from the Starship after the spacecraft has launched and returned back to Earth. The Starship will enter the Earth's orbit, and at the same time, a refueling tanker will be launched to meet with Starship that will refuel it once more. Once the Starship has been fully refueled, it will make its way back to Mars. The trip to Mars will take 9 months, and after its long, treacherous journey, Starship will be faced with the most difficult part of its journey, landing on the red planet. The atmosphere on Mars is equivalent to about 1% of Earth's at sea level, so landing on its surface will be incredibly tricky. Starship will have to enter Mars's atmosphere at a speed of 17,000 miles per hour, which is 25 times the speed of sound, and once it gets close enough, it will have to decelerate to reduce heat. Then it will perform a specific, first-of-its-kind maneuver in order to land on the red planet's surface. So after landing on Mars, what comes next? What will our first humans do when they get on the red planet's surface? The first priority is self-sustenance. The first humans will have to create a habitat on Mars that will be conducive for them. They will have to create shelter against the thin atmosphere, find a way to grow their own food, and source water from Mars's ice caps. And they will have to do all of these things at the same time. This is how they're going to do it. In the first few days, the Starship will be their base. There is a lot of dangerous radiation on Mars's surface, and the dust is so fine that it can find its way into spacesuits. So activities outside the rocket will be managed by the robots. These robots will get busy building a shelter that will be very close to a model that has already been developed here on Earth. The model we are talking about is based on a design by an architectural agency called AI Space Factory. AI Space Factory is a They came up with a blueprint for building 3D printed living spaces on Mars called Martia. Martia stands 4 stories tall and resembles a beehive or an egg standing on its end. Martia will be made by mixing a type of crushed Martian soil called regolith with a plastic-like polymer. It will have around 800 to 1,000 square feet of space and will be able to house 4 astronauts for up to 2 years. It will also be very effective at protecting our settlers from dust. This will most likely function as both a living space and a lab, depending on how many of the structures are built. Unsurprisingly, robots will be the ones doing all of the heavy lifting. When they are done, our settlers will have to manually install control systems, life support systems, power systems, docking ports, and airlocks so that people can perform spacewalks to repair or upgrade machinery. After this, or whilst they are creating their own shelter, another group will be solving the problem of how to make their food, water, and medical supplies. For food, the major focus will be figuring out a way to grow plants on Martian soil. The problem with the soil on Mars is that it is regolith. We have regolith here on Earth, and you have probably seen it before. It is a blanket of loose rock and dust and is incapable of holding or nurturing plant life. It might have essential minerals that plants will eventually need, but it doesn't have the organic matter and soil bacteria that plants need to grow. To make matters more complicated, Mars's regolith also has high concentration levels of toxic salts. So the major task would be turning regolith into arable soil. The process will be complex and incredibly difficult. They will need to remove the toxic salts, which are also known as perchlorates. Then they will have to regulate the pH levels of the soil till it has the right physical and chemical properties. They will ensure that it can retain enough water to support life, but not so much that it cannot drain. Then they will introduce microbes, small organisms and organic matter into the soil. In the movie The Martian, Mark Watney, the central character, does this by mixing Martian regolith with human feces. It is an effective method, even though he might have forgotten to remove the perchlorates. However, if our Martian soil scientists remove the perchlorates successfully, then they can make the soil fertile by adding compost, treated sewage, and small organisms like earthworms, or should we call them Marsworms. Alternatively, Mars colonists could resort to farming without soil. There are higher-tech, soil-free methods such as hydroponics and aeroponics that involve immersing a plant's roots in nutrient-laden water, hydroponics, or in a mist of nutrient-rich water, aeroponics. Instead of relying on soil bacteria, the nutrient levels will be managed electronically. These techniques have been used to grow a wide variety of plants on Earth, such as tomatoes, lettuce, potatoes, and cucumbers. However, we cannot do much with Mars's soil, and we cannot grow food if there is no constant supply of water. And we can't bring water from Earth to Mars because it would be far too heavy and impractical for transport. So where will our first settlers find water? Thankfully, there is plenty of water in the form of ice on Mars's surface. Some cover poles and others fill huge craters. So our Martian colonists would have to locate those ice deposits. In most cases, they will have to drill for it before they can extract it. Alternatively, they could also extract water from hydrated rocks. On Mars, there are rocks like gypsum that contain water, and if they crush it, bake it, and condense the extract, they will successfully collect the water. After collecting the water, they will also need to process it. The water will definitely be full of harmful impurities like heavy metals or salts like perchlorates. So it will need to be cleaned and desalinated before it can be used. On Earth, we have already gone far in the process of desalinating water. However, our major challenge with Mars will be the unknown. At the moment, we cannot say for certain what contaminants to expect in the Martian ice caps. The last step will be healthcare. With our Martians now 348 million miles from all the hospitals and pharmacies on Earth, they will have to create their own. In the Martia labs or in the greenhouses set aside for the development of food, our scientists will use an artificial leaf that was designed by scientists on Earth to thrive under harsh conditions. This leaf is made of silicone rubber and can use minimal sunlight to create the necessary chemical reactions required to make molecules for pharmaceuticals, agrochemicals, and solar fuels. When a working, self-sustaining system has been established, Mars will become habitable. Now, you might be wondering, is that all? Is this what it means to terraform a planet? Yes, many people imagine that a terraformed Mars will look like Earth. They believe that before Mars can support human life, it will have to look like it can support human life, like an Earth 2.0 with greenery and bright blue waters. But that is false. Terraforming is more about making Mars's environment supportive to our needs and less about building a sci-fi utopia that could aesthetically pass off as our home planet. Everything we have mentioned so far, the process of sourcing water, growing our own food, developing medicine, and building our shelter, these are all steps towards terraforming Mars. But if you really want to know if Mars will ever look like Earth, well, the truth is it will take some time. But for now, we can be content with the fact that we know we can make it happen.